Okay, good morning and good afternoon, everyone. This is Karen Maurikas. I'm the president of the Southern California chapter. This is the last webinar that we'll be having this year. Next year, we plan to have more, and maybe we'll even be in person, but you never know with all the things going on, all the different variants with the coronavirus. So, but keep your fingers crossed that we can meet in person next year. So let me try to advance the slides. All right, so today, in case you heard any of the kind of chatter before we started, Justin Knowles, who's one of our board members, he was actually planning on hosting this webinar and doing all the talking. He's having difficulties connecting, so unless we're hoping that he'll still be able to connect via phone and we'll be able to listen to him. But in the meantime, I will start. So this is what we'll be covering today. We'll have a quick introduction, and we always do a trivia question. We'll talk a little bit about the Southern California chapter activities, and then results of some of the polling that we've held in previous sessions. Then we'll get into our program. We've got 2 speakers today, and you'll see that shortly. And then we'll talk a little bit about what we're planning to do in 2022, and then wrap up this session. So moving on. All right, our trivia questions. So what you want to do is go to your chat window and you want to respond. You should just be able to respond, but you can select, make sure you're not responding to everyone. I don't think you have that option. But the question is, what year was ICEA formed? And so we're looking for a specific year. So if you happen to know that the answer, or if you have a guess, just answer it in the chat window, and later on we will revisit all of the responses and see if anyone got it correct. And for the winners, the winner will receive a Southern California chapter coin, which you'll see towards the end of this webinar. All right, again, we want to introduce the Southern California Chapter Board. If you've been on the previous webinars that we've done this year, we've always show who we all are since we're not in person. So on the top row here, we've got our officers. We also have our Region 7 director. And then on the bottom row are the directors at large. And I'm just going to point out right now, Justin Knowles, he was planning on being the host today. And so far, I don't see him on as a panelist, so not sure if he'll be able to take over that role today or not. We will also be hearing from Hank Apgar, hopefully Lisa Colabella. She's also having difficulties with being able to connect to the webinar, and then Mike Pfeiffer. All right, and I also wanted to recognize the volunteers who have helped us throughout the year in various different roles, or finding speakers, or just helping out in whatever way we need help. All right, and now I will turn it over to Hank Apgar. So it looks like you are off mute. Okay, go ahead, Hank.
Yes, this is Hank. I'm hoping you can hear me, Karen.
Yes, I can hear you, so I'm assuming everyone else can too.
Good. I'm happy to report on a major project for this past year by your local chapter. It is to develop a design to cost course, and we will make this course available to the national office as soon as it is approved sometime next year. The project is being led internally by David Bloom, who is our vice president, and we will have initially a version that's 1 hour long, can be teachable by most anyone who has a knowledge of the subject, and will be limited, of course, to an overview and general applications, neither hardware nor software, but generally. The course is currently in outline refinement stage, and that means we're improving the topic list, the outline, and the dynamics to make it of interest and also easy to present. Early next year, we will complete our outline and our draft content, and we will submit the draft at that point for comments by the members and ultimate review by IKEA International.
Okay, thank you, Hank. And just one more comment on that. When we will be soliciting comments, and in fact, we may actually present the outline in a webinar so that you can see what it is that we're looking at and have a conversation going back and forth so that we can get some feedback to make sure that we've got the right content for this particular level of course. All right, so now, okay, I guess we will do a trivia status check. Chelsea, has anyone responded to the trivia question?
Yes, we had a few people and only one got it right.
Okay.
Amrapal Agar said 2012.
Right. Okay, congratulations. So ICEA, for those of you who don't know, ICEA was a combination, was formed from a combination of ISPA and SKIA. And before that, there were some other organizations that were involved. And so if no one had gotten the trivia question correct, we were going to give you some hints here and then let you know, okay, hey, well, category D, okay, now come up with a number. But congratulations again to our winner. And we can move on with our program. So now you know when ICEA was formed, right? Okay. We wanted to show a little bit about what you had said in previous webinars. And again, if you had tuned into our last webinar, you would have seen the same slide here. We just wanted to know what people thought of when they heard the term ICEA. And so you see that, this is a word cloud. The bigger the words, the more often it appeared in the responses. So you see lots of things, about community, about certification, obviously cost, technical cost, intersection, lots of things going on here. So again, just wanted to share that with you, sort of a fun trivia fact maybe. And our second poll that we want to share with you is we had asked in both of our webinars, previous webinars this year, what topics were of interest to you for future webinars. And so each of these boxes is a response from a different webinar that we presented. So you can see some of the same topics are in both of them. The reason we're showing this is if any of you feel comfortable in presenting and have something about any of these topics, let us know, and we'd love to hear you present on them. And today, just notice that we've got software cost estimating as one of the top ones up here, and we will be hearing more about software cost estimating approaches. And we will also be hearing about some of the best practices. Well, I see we've got the word best practices here, yeah, anyway, moving on, just keep this in mind if you ever have a topic that you'd like to present. All right, we'll skip this one. Okay, now for our program, and I see we have Mike Pfeiffer on. So Mike, why don't you go ahead and introduce our first speaker?
Thank you, Karen. Yeah, so Mike Pfeiffer, I'm one of the ICEA SoCal board members, and it's my pleasure today to introduce Ms. Anandi here. Anandi's a cost analyst at Technology Research, where she researches innovative cost estimation methods for traditional and agile software development programs. She received her PhD in software cost estimation under Dr. Barry Boehm at USC. And for her research, Anandi collected data and calibrated the Kokomo 2 model to include functional size metrics. Her research interests include software metrics and its application to project management, software cost estimation, and software process improvement. And so with that, it's my pleasure to hand this over to Anandi and her presentation.
Thank you, Mike and Karen. So this study is going to look at different software functional size metrics. So if any of you have looked into software estimation and software size metrics, you'll know that there are a lot of different variants of function points. So we're going to look at how they compare empirically. Before I do that, This is a collaborative study with a lot of different people coming from different organizations, and I'll explain what role everyone played in this study soon. But basically, we wanted to look at the different kinds of function points that different organizations are using and how they all kind of compare to one another. Okay, so here is the basic outlines. I'm going to go over the motivation for this study and the methodology used and results and conclusions. But if you look over to the right here, this is the outline for the paper that went with this presentation, and this was submitted to the ICEA workshop. So you can find the full paper on ICEA's website. Of course, it will have a lot more information. It'll go into how to calculate all the different kinds of function points, and then go into the results with more detail than I can go through in the presentation. All right, so let me get into the motivation. There are essentially three groups or categories of software size metrics. We have our traditional source lines of code, which is easy to use, especially when you have a completed program. It's objective because a line of code is a line of code for the most part. Of course, there are some discussions about programming languages and programmer experience or skills that might affect that count. But for the most part, it is a measurement of the completed effort of the software development. And then we have function points that had started, I think it's like the late 70s or so, where instead of using software lines of code, we wanted to look at the software and the functionality at a higher level in order to get an accurate size metric. So the first one that was created was ifpug function points, and after that there have been different variants. And then there are the agile metrics. And the agile metrics have focused primarily on using even more higher level type of metrics so that the teams themselves can quickly and easily manage their projects and figure out what it is that they would be able to accomplish or work on at a time. So because of the different characteristics, and the pros and cons are listed on this slide, but essentially function points is a nice balance between the objectivity we get from source lines of code and the high level, easy to calculate kind of characteristics we get from agile metrics. And that's one of the reasons that I'm looking at function points specifically for this research. Okay, so as I mentioned, ifpug function points was the first variant of function points that was created. What they did was they looked at software and tried to figure it out. What is it that software does generally? So they came up with this model, and what it explains is that you have your software system, and it essentially will get inputs or provide outputs or a combination of them, which is called queries. And then we either have internal storage that we either save data to or read data from, and we might be grabbing data or information from external sources. So those are the main modules for the software system. And then each of these transactions, you'll see these boxes with numbers. Each of those transactions are given sizes according to the number of data attributes or elements that are being passed through those transactions. It's a way to try to give a size to these different things so that we can differentiate between a small, a medium, or a large transaction. And our storage is also given a size as well as how much external data we are gathering or pulling in. So a lot of people have found using function points to be very useful for their estimation processes. And despite that, there have been three general categories of complaints or issues with the use of function points. And the first one was that people have found it typically a little bit tedious to calculate upfront because you had to understand the different functionalities and transactions that your software system needs to perform, And then you needed to count how many data attributes were associated with each of those transactions in order to get an estimate. So because that process is so tedious, one solution that had been introduced is called simple function points. And what simple function points does is it reduces all of your transactions into just one group or category, and then all of your storage is one group or category. And instead of having 3 possible sizes, you just have 1 possible size. So now all you need to do is figure out how many transactions and how much data you're using overall, or how many data sources you're actively pursuing or grabbing data from. And so that simplifies the counting process significantly so that you can get counts earlier. Another issue people have noticed when they were either building very small or very large systems, and by small, mostly when we start to get into modifying existing software systems, is that the current low, medium, and high sizes available to us through IFPUG function points doesn't let us differentiate between very small and small or very big and big. And so there is another type of function points called cosmic function points that were developed, where it allows you to calculate or count each individual data group. Instead of getting a low, medium, high size, you can customize your size of your transaction, but that would be based on the number of data groups that are associated with that transaction. So this will allow you to have a very small compared to small, and allows you that higher granularity. And finally, another issue that had come up with function points is that it can be very difficult to get your actual function point size after your project has completed, because a lot of times your architectural or your documentation that's supposed to explain the software you are building is not representative of the actual software that was built at the end of the project. And by that point, the team has moved on to working on new projects. So no one wants to have to go back and make changes to the documentation and to calculate your actual function point size. So there are developers at ODNI that are working on what's called objective function points. And the idea here is to look at the final completed source code and calculate the actual function points or functional size of your project based on the code. So what I'm going to do in this study is I want to compare IFPUG simple and cosmic function points, because we're either reducing or increasing the amount of information from IFPUG, and then look at objective function points and see how well it's able to get the actual functional size compared to those 3. And I'll go over that again in a little bit. All right, so let me just put in a little note about effective sizing. So with source lines of code, we use effective sizing in order to modify or make our size equivalent to new code when we're making modifications to existing code. The functional size metrics currently don't have a method to do this. They do have a method to calculate your modifications, but it's not equivalent to a new development size. So there are organizations that we collaborated with on the study that use effective sizing, much like we would for source lines of code or SLOC. And so we're going to use the same thing here in this study. But again, this is not part of the original IFPUG simple or cosmic function points counting methods. All right, so speaking of methods, let's get into what it is that we are actually doing and did. So first of all, we grabbed data from USC's Unified Code Count Enhancement Tasks, or UCC for short. I was part of that team at USC when I was doing my PhD there. So we were able to get all of the data that we needed to be able to calculate all of these different kinds of function points. And that's why we're using this particular data. And this is where I'll share or explain how the different collaborators, what their roles were in this study. So Ian Brown is a SME for IFPUG function points. So he calculated the IFPUG function points for this study. We didn't have a SME or an organization that used cosmic function points. So I used the counts that I did for my PhD dissertation. And then DHS and NSA both use simple function points. So both of the collaborators from those organizations used their methods to calculate simple function points. And as I mentioned before, OD and I have developers that are working on objective function points. So they were in charge of getting the final objective function points from this data set. And then I took all of the different sizes and compared them to effort or the objective function points to these other function points to see how they all compared, how they behaved, what are the conclusions of which ones we could use. Okay, a little bit about Unified Code Count. So Unified Code Count is maintained at USC along with IAI, or Integrated Apps. And so the data set that we have is the work that USC in particular had done. And since I was part of the team, we had access to their requirements, to their documentation, to their code, to anything basically we needed in order to calculate the function points. And for those of you that are not familiar with what UCC is, it is a command line program. It does now have a GUI, but most of the data points here are for the command line program that takes in source lines, or actually source code, and it gives you your logical and physical lines of code counts, as well as some other code-based metrics. So what we will see that is important in the actual results is that we had 3 major levels of complexity that we could group these projects by. We had the low complexity projects, we had average, and then very low. And you'll see why that's important. How they're differentiated is explained in the paper. And in the paper, you'll see that there was also a difference between when we were adding new features or modules and modifying existing ones. But I'm not going to go over that in this presentation. So again, if you'd like to see the difference, I suggest looking at the paper. All right, so before we get into the results, I wanted to share or explain how all the different things I threw out there until now all come together. So we have in the paper these different types of size metrics that I compared and looked at. And I'm going to break down how they're all different. So the first way that they're different is, of course, by the function point variant that they represent. So of course, we're looking at cosmic, IFPUG, simple, and objective. But then within each of those, you'll see that I have underscore and then some names or some letters. And that represents either who counted them or the organization that that particular metric came from. So these first 2 are ones that I calculated for my PhD dissertation. The next 2 are from Ian Brown. This next one's DHS, Cadence or NSA. Cadence is the tool that NSA uses. And then we have our objective function points. We have objective function points and then objective module points. There's a slight difference because when the developers started their initial objective function points, they found that it was getting too much information compared to the actual function points. So then they had to make some modifications, and that's what the objective module points are. All right. Now, these are also different based on the kinds of inputs and the way they were calculated. So I'm going to go into that a little bit. So when I calculated the sizes for my dissertation, I calculated it based on the actual functionality because I wanted to get the actual functional sizes of the projects. And then I created requirements based on that because, again, I wanted to get the actual functional sizes of the projects. And I provided it to all of the collaborators on this paper so that they could calculate their function points. And of course, since objective function points is based on code, I provided them the code for each of the projects so that they could do the calculations. Okay, so as I said, the first two were done by me and some colleagues, and Ian Brown did the next two, and all four of these were done manually, so they were calculated manually using the requirements. DHS and NSA have tools to automate their counts. So DHS has an Excel tool that they use where they extract the verbs from the requirements to calculate their simple function points. And NSA uses the tool Cadence that's developed by Log Apps, and it does a similar thing except that it's a web-based tool. And ODNI have developed their objective function points functionality in UCCG. And so that's the tool that they use to get their automated counts. And here is an example of a single data point and how the different sizes from the different methods differ. In the paper, I explain that while function points claims to have the same size as long as you have certified counters, there are projects like UCC that don't always fit within your typical function points type of project. And that's why we see a difference in the sizes. And again, that's explained in the paper. All right, so now that you understand all the different sizes used and how they're calculated, all of the ones that are based on requirements, so that's your function points, IFPUG, simple, and cosmic function points, I compare all of those to effort to see how well they could be used to estimate effort and cost. And then I look at the objective function points and see how well they are able to estimate IFPUG, simple, and cosmic function points. The reason I do that in that way is because your simple objective simple IFPUG or cosmic function points are meant to be used to estimate your effort and cost based on the requirements. And then you would grab your objective function points at the end of your project, and you can use that to update your database of your software efforts so that you can calibrate or update your estimation model. So that's how the IFPUG, cosmic, and simple are different from objective. They're used for two different purposes. All right, so let me get into the results. I only looked at one sample from each of the different variants of function points in this presentation. Again, the paper will go through each of those different metrics I went over individually, as well as a comparison across all of them. So here I'm just going to look at generally how the different kinds of function points differ from one another. So starting with IFPUG here, the original function points that was developed, we can see here that for the most part, we see a positive correlation between size and effort. But if you were to look at all of the data groups together without the colors and the groups that I created, while there is a pretty strong correlation, there's also not a very perfect trend here, right? Because we have these stacks of data points stacked at 5, stacked at 12, and then some data points that don't really fall into these stacks. So remember, I told you that function points looks at inputs and outputs as your transactions or reads and writes from data storage. And that's why, and they are all given specific sizes based on the sizes of those transactions. So for UCC, where we're getting input files and we're reporting outputs, all of these projects are essentially either giving you one piece of output or maybe a couple. And then some other projects, for instance, when we created options for new inputs or outputs or new reports, those ones might be a combination of multiple inputs and outputs. So that's why we see this stack of data. But if we further group them by complexity, we see that the trends between size and effort increases, and that those complexity groups kind of stack on top of each other. So that tells us that IFPUG function points doesn't do a good job of sizing complexity. You have to account for that separately in order to get better estimates. And of course, it's not part of the calculation steps. It's only looking at inputs and outputs, nothing related to complexity. So you would expect to see that. Now, simple function points removes certain granularity in order to make the estimation process easier and faster. So we want to look at whether we lose accuracy or effectiveness by going from IFPUG to simple. Now, in the case of UCC's data set, we see that we don't lose very much accuracy or effectiveness at all. And that's because UCC's projects were all, for the most part, very similar to each other, which we could see size-wise, but also the projects themselves were very similar to each other. So that's why we don't see a loss of accuracy moving to simple function points. That's not to say that we wouldn't see that in other kinds of projects. Finally, with cosmic function points, we see that there is even stronger correlations between size and effort, and that's because we are using more information and getting a better assessment of the sizes using cosmic function points. All right, and objective function points, I'm not going to go over in that much detail, but what I want to say is that the objective function points methodology was based on the IFPUG function points methodology. And so not so surprisingly, there were better correlations or estimates between objective and IFPUG function points. Again, and this was not to be expected, but at least with UCC's case, we found that that does differ by complexity level, however. Now, ODNI is still working on further calibrating and improving their calculation of function points based on source code. And those two things are very different from each other. So that's a very challenging project to take on in the first place. So we hope to see that this improves over the time. All right, so let's get into our conclusion. So the main questions that I tried to answer with this study are, is it feasible to use function points in order to estimate size and cost, effort and cost? And for the most part, I would say that my results here show that yes. However, you have to be aware of the fact that function points will not account for complexity in any way. So it would be best to group your projects by complexity in order to get better estimates. Now the question is then which variant of function point should we use? And that really depends on what estimation attribute is most important to you. So if you're looking to be able to make estimates quickly, then you'll want to use simple function points. NSA and DHS have come up with methods on how to do that in an automated way so that you don't even have to do the manual process of calculating them yourself. But if accuracy is more important to you, then you'll want to look at cosmic function points. But if you want to be able to get your actual functional size count automatically and quickly and easily, then objective function points did better with IFPUG function points. So again, they're all different, and because they're all a little bit different, they all have their strengths and weaknesses. So which one you want to use would really depend on what's most important. Okay, so let me conclude with that. And I see that I have a question, so I'm going to go ahead and look at that and see if I can answer it. All right, so I just see I have a question, but I'm not sure what the question is. How do we typically handle questions?
Hank, I think you can unmute yourself to ask the question.
I could just speak the question if you can hear me.
Yep, I hear you.
This is Hank Apgar. Dr. Hara, I'd like to say, first of all, this is the best paper I've ever heard on function point software estimating method, and in particular your comparison to SLOC, source lines of code. I say this because for many decades I've been frustrated with trying to explain to my customers of my estimate that I use function point instead of source lines of code. And the reason I have trouble explaining that is because every estimate has to be credible, and most of my customers have heard of Barry Beam, and they know of his work going back to 1981, which was based on source lines of code. So even though you give a very convincing argument in your paper, how can I convince my customer quickly that I've used a method that is as good as or better than being based on SLOC, which everybody visualizes as an output of labor and therefore is easier to estimate?
That is a really good question.
I do have a follow-up question if you have time, but I'll hold that.
Okay, yeah, let me answer that one. And first of all, thank you for your comments on my paper. So, you know, when you look at new development projects, and especially, I would say, older ones or ones that are built more traditionally, SLOC has a really good correlation with effort, very strong one. But as we start to see that the way software is developed changes, now we're using reuse code a lot, we're using systems, we're not actually coding and building a lot of the software ourselves so much anymore. And now with those systems, we're seeing that SLOC doesn't have quite a strong correlation with effort anymore. But while that's true, even for the projects where the effort is highly correlated with SLOC, estimating that upfront is very hard. So I know a lot of people look at Dr. Bain's cone of uncertainty and they say it applies to the uncertainty that comes with software itself, but that cone also shows how much uncertainty there is in estimating SLOC itself and not just cost. So it's very difficult for people to estimate SLOC upfront. And there was a paper that was done, I think, a few years ago. I can look it up, but it's in my dissertation. I refer to it, where it looked at people and how confident they are in their estimates and the accuracy of their estimates. And they found that there was no correlation between the two. So there's no way to really know how good a SLOC estimate is, essentially. And you can't use the estimator's confidence in order to see how good it is either, or to gauge how accurate it is. So definitely function points is better from the estimation standpoint, where we're using actual functionality and the understanding of them to estimate the size. So I would say that that is the argument that you could focus on. And also because it's based on functionality, you can more easily use it for the cases of reusing code or using systems or platforms or services, and not where we're not necessarily building code, but now we can define the code that we are having to build better.
That is very useful to me, and I appreciate your candidness. I do have a follow-up question if you have time for it.
I'm not sure how much time I do have. Karen or Chelsea, do we have time for another question?
Right, I would say you have time for one more.
Okay, great.
All right, this is a shorter question to answer. I have a big inventory and a big investment in databases, which date back probably to the same time that Barry Bean developed his first model. But they're all based on SLOC. I don't want to just chuck the database or databases and start over. Is there any convenient method or any convenient approach I might use such that I might calibrate my original databases? And I'm talking about the databases funding mostly by the US government, SMC.
All right, so there have been research, and Capers Jones published a book on using conversion methods from SLOC to function points. And you can definitely try to use that. I would say take that with a grain of salt, though, because while these papers will claim that it's a pretty accurate way to estimate function points from SLOC, or a way to kind of convert between the two, one of my first papers I wrote was actually doing that with the UCC data. And in the case of UCC's data, there was zero correlation between function points and SLOC. So the point I'm trying to make there is that they might not be highly correlated for all projects. It might depend. So you'll get an initial function points count, but it might not be very accurate. And now that you are doing a conversion, so that's going to have a layer of error based on that regression model or that conversion method. You're adding on an additional layer of error to your estimates based on that. So it's difficult to do that if you know what the programs are and you have a high-level understanding of what they do, then you could possibly count the function points yourself.
I think that's a good answer, particularly since I was the contractor who developed a good part of the SMC software cost database. I do know the original programs. The other problem is it's very old data, but that's not a problem related to your paper. Thank you again for your answer.
Thank you.
Okay, and Anandi, I do see one more question. Andrew Osadolor, maybe, sorry if I'm mispronouncing your name, is asking if there's a link to your dissertation, or if not, if it's not in the presentation, can you send it to the ICEA office so that we can share it with the audience?
Yeah, I believe I do reference my dissertation in this paper, but I can look for and provide the link to ICEA to provide that.
Okay, and is there a link to your paper in this presentation?
No, it's not in the presentation itself. You'll have to go to ICEA and look for the title in order to find it, or to look at this last year's proceedings to find it.
Right, okay. All right, thanks. And Chelsea, are there any other questions that have come in via chat?
Nope, no other questions.
Okay. All right, well, thank you so much, Anandi. Very interesting. I have questions that I'll follow up with you afterwards, but I don't want to take any more time away from our next presenter. And our next presenter, first of all, is Lisa Colabella able to unmute herself?
Yes, I'm on.
Okay, great. So Lisa is going to introduce our next presenter, and I'm going to try to share my desktop again.
Great. Well, good afternoon, everybody. It's a privilege to introduce Mr. Brian Bothwell. He's the Director of Engineering and Technology Assessments on GAO's Science Technology Assessment and Analytics team. He has 25 years experience in the cost estimating field, and he's a certified cost estimator analyst. Prior to joining GAO, the Government Accountability Office, in 2013, Brian spent several years as a support contractor to the federal government in the area of project controls, and he served as a U.S. Navy officer as well for 20 years. Brian holds a master's degree in operations research and a bachelor's degree in chemical engineering. We look forward to hearing his presentation, which is called GAO Best Practice Guides. Brian, over to you.
All right, thanks, Lisa, and thanks, Karen, for inviting me to present to the group. And thanks, everybody, for attending. I've got a good number of slides, so I'm going to proceed through them pretty quickly so we can make room for questions at the end if there are any. I'm going to talk about GAO's best practice guides, a little bit about their structure, the criteria in those guides, and then I'll give you a taste of some of the audit results that we've generated from using those guides to do some of our GAO reports. But first, I want to talk a little bit about GAO for those who may not be familiar. So you can go to the next slide, please. So GAO is an independent, nonpartisan agency. We work for Congress, and our goal is to improve the performance and accountability of the federal government. There is one political appointee at GAO, and that is the Comptroller General. And he's appointed to a 15-year term. I think our current Comptroller General has about 4 or 5 years left. And just as a side note, he is the first Comptroller General who actually worked his way up through GAO. So he has been at the agency for a very long time, and he has very deep knowledge of the institution. You go to the next slide, please. Our work is primarily done at the request of congressional committees or subcommittees, or it is mandated. It's put into public law, or it's in a committee report. That is the majority of our work. But we also can undertake research under the authority of the Comptroller General, which we do to create our best practice guides. Next slide, please. And here's some examples of the work GAO does. The big majority of the work done is doing what we are called performance audits, checking the performance and efficiency of various programs in the executive branch throughout different agencies, Homeland Security, Defense, Energy, and many more. And there are also some other activities we do, including investigating fraud allegations and issuing legal decisions and bid protest rulings. Next slide, please. So these are the four current best practice guides related to program management, project controls areas. The primary purpose of the guides is to give our auditors audit criteria, but they can also provide agency guidance for those agencies that do not have their own guidance. And this was part of the impetus for developing the first cost estimating and assessment guide, which was issued in 2009. What we found is that there were some agencies that had criteria for doing cost estimating, and there's some agencies that did not. And so we pulled together an expert panel, so I'll talk about in the next slide or two, to help GAO develop a cost estimating guide, which we then use for audit criteria, and can also be used by agencies, as I said before. The original cost estimating guide contained an appendix on scheduling. We found that the scheduling topic was really rich enough and large enough that it deserved its own guide, so we developed that, issued that in 2015. And we've also developed a technology readiness assessment guide, which was published in early 2020. And the first draft of an agile software development assessment guide was published in September of last year. It was originally started by looking to address the project controls in agile software development, because we ran into some organizations who were insisting that they didn't need to do cost estimates, they didn't need to do scheduling because they were agile. We disagreed with that, and I think some other parts of the community have also disagreed with that aspect, but agile software development was different enough that we wanted to address doing project controls with agile programs. After starting that guide work, we worked with other teams in GAO, and it expanded into more of a assessment guide for several different criteria related to agile, including implementation, metrics, contracting, in addition to project controls. Next slide, please. And so we don't just write these guides ourselves at GAO. We involve experts from the community of practice across academia, industry, and government to help us to build the guides And one example is we had a cost expert group that was established way back in 2005 and met twice a year through 2020. That group of experts grew to be very large, and they helped us to build the very first cost estimating guide. And once we got that group going, we expanded to other topics. We also included earned value, which was incorporated into the cost estimating guide, and some other program management topics such as scheduling, which, as I said before, was first an appendix, and then it was its own guide in 2015. Similarly, for the TRA guide and for the Agile guide, we assembled groups of experts from those areas to help us develop those guides. And the Agile guide right now is in what we call an exposure draft form. It was published last September, open to public comment for a year. We've got those comments, and we're about to restart the project, and we'll be reconvening the expert group to as we vet those comments and update the guide. Next slide, please. I'm going to talk about the cost estimating guide a little bit here. And let me make the point here, also talking about the guides, is our comptroller general likes to call these open book tests. We publish these criteria for cost estimating, scheduling, TRAs. They're public documents. Everybody can see what they're going to be assessed on. They know the criteria. And we highly encourage the agencies to take a look at these guides, especially if we're going to come and look at their work. Next slide, please. So the basic structure, there's a couple of introductory chapters. Chapters 3 and 16 bookend the meat of the cost estimating steps that we've defined, which are described in chapters 4 through 15. The cost guide also contains 4 chapters on earned value management and has several appendices. You go to the next slide. So this was the starting point. This experts helped us develop this 12-step process. So we identified what are the steps that have to be done to create a reliable estimate. And as you can see here, this is not anything provocative. It's defining the purpose, developing a plan, defining the program, collecting data, ground rules and assumptions, developing a point estimate, and doing your analysis on it, and so on. So that's the thing. That's what we started with we developed that back from the 2009 guide. It is also in the 2020 guide. There are no changes here. And if you go to the next slide, while we looked at the 12-step process, we also identified 18 best practices, which are listed here in the blocks. And we defined 4 characteristics of a reliable estimate as a way to group these 18 best practices and allow us to better describe the comprehensiveness, if an estimate was well documented, if it was accurate, if it was credible. Those are the 4 characteristics we identified and defined for these various best practices. And if you go to, thanks. So I'm going to go through a couple examples. One here back in that's the 2016 report. We looked at a NASA program, and in this case, NASA had already established a baseline of 11.3 billion and a launch readiness date. And I think some of you are probably familiar with NASA's process for using a joint cost and schedule or confidence level or JCL analysis. So they set their baseline, and then the next slide, GAO was asked to look at the cost and schedule estimates underlying the program, and we found some issues. So for example, when looking at data, we found that some of the source data really lacked support. So there's a documentation issue. We couldn't trace where the data came from, so it called the reliability of the data into question. Another thing we found was that the methodology that was used was lacking in detail, and would make replicating the work difficult. It would also make oversight of the work or double checking the work difficult. Another documentation issue. And then we also found a problem in the comprehensive area in that the estimate did not link directly to the program's technical baseline. You couldn't show how the estimate was based on the technical baseline. So that was another issue we found. And so the bottom line is on the next slide was our conclusion was if you don't have a reliable cost and schedule estimate, then you really don't know how good your JCL analysis is either. And we recommended in this case both that the NASA update the cost to schedule estimate to make them reliable and reperform the JCL analysis. For the 2020 census, we were also asked to look at cost and cost estimates. And back in 2016, and I'll make this point for both the census and NASA. These are from 5 years ago, so situations have changed. This is just a snapshot of the point in time we looked at it. Here we found a problem in the among other things, we found a problem with the risk analysis that the census did, because they only did risk and uncertainty on a portion of the estimate. And we found that their $12.5 billion estimate at the time, they were only conducting an uncertainty analysis on about a little more than a third of that. So next slide. And then in addition to that, they added a management level of about 10%, over $800 million to the total estimate, but they didn't have any basis for it. They just added 10% on at the end. So if you go to the next slide, you see there's a pie chart which kind of describes on the right what that was. So if you look at the modeled costs, that was what the Census Bureau was calling the portion of the estimate that they did the risk and uncertainty analysis only amounted to 37% of the overall estimate. 52% of the estimate was not modeled, in that it was essentially pass-through inputs from other parts of the Bureau, and there was no risk associated with that. So in conclusion, we said, well, we couldn't really identify the level of risk. The Census Bureau presented a confidence level on the 37% portion, but they didn't really have a good idea of what their overall confidence level was. Let me just say before we go on from this one that they greatly improved, but before the 2020 census occurred, we evaluated them as having a reliable cost estimate, and they did a very good risk and uncertainty analysis. Let me talk about Technology Readiness Assessment Guide. On the next slide, its structure. Similar to the cost guide, the criteria are described in a step-by-step process. And the TRA characteristics are all summarized in one section. The characteristics with their associated best practices, just like I talked about with the cost guide. So on the next slide, we see the 5 steps that we use to conduct a high quality TRA. And let me just pause here and say the TRA guide, also like the cost guide, is telling the auditor how do you assess a technology readiness assessment, but it can also be used by an agency that needs some guidance in how to do a technology readiness assessment. So these are the 5 steps. Again, one's preparation, identifying critical technologies and assessing critical technologies, creating a report, then using the report findings for management action, milestone decisions, development of a technology maturation plan, which the TRA guide also includes a whole chapter on technology maturation plans. If you go to the next slide, the next space lists all the best practices that we've identified here, but the 4 characteristics are here because we identified, without expert help, 29 best practices. If you go to the next slide, here's a general description of the 4 characteristics. So talking about credible, we're talking about understanding the requirements, understanding the environment, and the technologies interaction with other components or technologies. Objective, we're looking for is it good data that's being used, and are the decisions and actions you're planning free from bias or influence. Reliable, we're looking for a disciplined process, and if it's useful, if it provides information that has sufficient detail, it can be acted upon by decision makers, or for the development of TMP. I think the next slide takes us to an example. I'll run through some examples where we used this recently. We did an audit recently on the DHS's program called BD21, Biodetection for the 21st Century. And this is sort of an iteration after the previous program, BioWatch, which is a biodefense program started after the 2001 anthrax attack. What we found when we went into this, we thought we were going to be looking at their technology readiness assessments for their critical technologies, and we found was they were a little bit early on in the program, more early on than we thought. And so they didn't have these TRAs performed yet. They were still looking at technologies, but hadn't gotten to that DHS milestone point to do them yet. So what we did instead was that DHS created a TRA guide during this engagement that we had. And so we used GAO's TRA guide and used the criteria there to compare what our TRA guide said to what DHS's TRA guide said, and matched the best practices to the activities that they outlined. And we found that their guide didn't fully incorporate all best practices at the point that they issued it, but we've had continuing conversations with them since, and they are changing it to align with the TRA or GAO's guide. Next slide. We also applied it to COVID-19 vaccine development. One of the questions that came up early on was, what steps are they following? What kind of technology readiness can you attribute to these various vaccines that are being developed very quickly? We use criteria from the GAO's TRA guide and TRLs, technology readiness levels, that were defined by HHS for vaccine and treatment development, to take a look at what the various companies who are developing the vaccines, how they were following, getting through the various TRL steps. And we found they generally followed traditional practices, but they had some adaptations. For example, some clinical trial phases overlapped with each other and with some animal studies. That was to accelerate development. So we didn't find that there was any skipping of steps. It was just they're still completing the necessary steps. Next slide, please. And the third TRA example, this goes back to a 2018 report. We looked at the technology readiness assessments that were done for the Columbia-class submarine program. And there have been two done at that time. There was one that was done for milestone A, one done for milestone B. And one of the things we found was that the Navy had changed their definition of critical technologies between milestone and milestone B. And we found that they were actually under-identifying the number of critical technologies they had. And so the graphic there shows you a number of technologies that we identified as that should have been called critical technologies, that the Navy had called engineering developments at the time. Anyway, the result of that was that because the work, Congress updated legislation to get the Columbia-class program to report on those technologies to Congress, because it would not have otherwise been required. Next slide, please. Then I'll just touch on AOA best practices, which are an appendix to the cost guide. And similar to the guides, these criteria are also described in a number of steps and summarizing the characteristics. And if you go to the next slide, you can see the 22 steps in the 5 phases of an AOA. And then to the next slide, we show, again, 4 characteristics So we've identified all the best practices that are associated with them. So when we assess someone else's AOA, these are the criteria we're looking for, and the 4 characteristics describe how we write about them. If you go to the next slide, let's talk about one last example. Another 2016 piece of work done on the amphibious combat vehicle. And here what we found is there wasn't just one AOA, but there were several products, an existing body of work that we found and we had to include in our analysis in order to really give a good look at the Marine Corps' work on this program. So if you go to the next slide. These are the findings, and this is a mostly good news story. Actually, it's a good news story by the ratings there. And it's one thing I haven't talked about earlier is when we give ratings to the various characteristics, we use a 5-point scale that goes from met, substantially met, down to partially, minimally, and not met. Substantially met and met are kind of they're passing grades for us. We don't make recommendations for improvements. We may find some things that don't necessarily follow every best practice. We'll identify them, but we don't typically put that into a recommendation if they get these kinds of ratings. And like the bottom bullet there says, it was just kind of like they didn't have a full list of assumptions and constraints. And the effect of that could be make it more difficult for decision makers to make comparisons. But overall, this was a pretty good result. If you go to the next slide, I want to thank you for being here today. I appreciate the opportunity to present. I know these slides are going to be posted on the ICEA website at some point. So if you want to go back and look at some of these, there are active links to all of the guides and to all the reports that I talked about. So if you want to do some more digging on your own, they will be up at some point. And then the last slide is just here's my contact information and also the contact information for the 2 assistant directors who run the engineering sciences group, which is the group at GAO that's responsible for developing these guides and for and basically has oversight of use of these criteria throughout the organization. And with that, that's my brief. So I'm happy to take questions if we have time.
Okay, thank you, Brian. Chelsea, do we have any questions in the chat?
No questions, but Hank does. He said that he has a question if no one else.
Okay, actually, Hank, before you ask your question, I did get a question come in from Tom Bosmans, and his question is, for the COVID-19 vaccine development analysis, which you showed on slide 24, and maybe I can back up to it. Oh, what am I doing? I'm doing the wrong thing here. All right, let me read the question first. Did the compressed timelines simply perform the same traditional tasks and scope on a 24/7 schedule instead of a standard 5-day or 40-hour work week, or were more modern automation such as bots or machine learning, simulation and or streamlining techniques employed?
I don't know the details of exactly how they did it. What the information that we got to review was reports from the companies that they had to make to FDA, HHS about how they had met the various technology readiness levels. So I don't think our report got into that. I don't remember having that discussion with anybody who did the detailed work on the report. So it was, we were checking to make sure that they really, no kidding, met the highest TRLs and were ready by the HHS TRL criteria to actually be a mature product.
Right. Okay. All right, and then Hank, you said you had a question.
Yes, first of all, Brian, this was an excellent paper. I particularly liked the inclusion of examples and lessons learned. I had not seen them before, and they make your points very well. I do have a question, however. A couple of years ago, I was in Japan, and I noticed that the Japanese government had a Japanese translation of your cost estimating and assessment guide. I'm wondering, first of all, was that legit? And if it is legit, is that something you plan to do with your updated versions?
Yeah, thanks, Hank. Yeah, that is legit. The Japanese government reached out to us after the publication of the 2009 guide, and they subsequently, and we of course would like to have our work distributed more places. So we were happy to say yes, go ahead. And they translated the 2009 version into Japanese cost estimating assessment guide. I haven't heard from anybody, but I also haven't reached out to anybody about the 2020 guide and if there's interest in translating that. So I haven't heard anything about that recently. We would be open to that if foreign governments wanted to do that.
I do know the Koreans would like to get a copy also in their language, and I encourage this activity to make your guides universally accepted.
Yeah, thank you.
All right, and then Brian, this is Karen again. I have a question. So you gave a lot of examples here, which I really liked, and in a lot of them, the GAO assessment found some sort of inadequacy. So typically, do you find that the majority of assessments of programs where the programs do not meet the GAO criteria or do not follow the best practices? And if that's the case, then what happens next?
Yeah, great question. That's part of this is a I don't know, bias is the right word, but I say it's kind of a biased selection process. Congress is much more likely to ask us about a program that they are highly interested in, a program that's having trouble, a program that they're concerned about. Then they're not, if they think the program's running fine, we're not going to be requested to go look at the perfectly running program. So there's a little bit of a, I guess, a selection bias here. So I don't know what the percentages are, and I don't think we really keep track of the percentages of programs that are doing well versus not doing well based on our audits. But there are some great cases where agencies have improved. I mean, we can make the case, I think, going back quite a while, that because of GAO reports that NASA improved their earned value management criteria and practices. One that I was involved in personally, I talked about in the briefing, was the 2020 census. When we first looked at the 2020 program in 2016 and looked at their cost estimate, we found plenty of problems, not just the one I talked about with regards to risk uncertainty, but we had data problems. We had no linkage to risk registers. We had a large number of pass-throughs, all these kinds of things. But what happened was that the Census Bureau took it seriously, and they invested in the cost estimating and budget people to improve the estimate. And so we went through a couple iterations, but the last time I looked at that in 2018, when I did the follow-up assessment on the program, they had greatly improved their documentation. They were applying risk uncertainty across all of the elements that made sense. Obviously, not all of them. Census was I think it ended up being a $15 or $16 billion effort. So there was a large number of activities involved in all that. So there are cases sometimes where we go in and we say, hey, this isn't good, and we can actually help those agencies, or get those agencies to pay attention, and they end up improving their processes. I was really hoping to find out what the 2020 census really cost, but unfortunately, by the time we got to the final estimate, then the COVID hit, so that changed everything.
Right. All right. So let's see, are there any other questions for Brian that have come in?
Nope, none that I see.
Okay. All right. Well, if folks have more questions for Brian, you can reach out to him like he showed on the slides. His contact information is there. And thank you again, Brian. I am going to go back to, let's see, the slides that we have. Maybe I'm going to get there. All right. So now, first of all, in the chat window, Chelsea has provided two things. One is the link to Anandi's paper. And so within that the ICEA paper, there is a link to her dissertation or information about where to find that. But then just more recently, Chelsea has sent out a link to a survey. For those of you who have been on these other webinars that we've had, we tried to do live interactive polling. We just weren't able to do that this time. So we're sending out a quick survey in the chat window. It's got these 4 questions in it. And ideally, the idea is to look at the survey right now and fill them out while we're on this call. We might be able to look at some of the responses. But really what we want to know is your preference going forward next year. Let's make the assumption that there are no COVID restrictions. So would you prefer an all-day workshop in person, or do you prefer 90-minute virtual webinars, or a combination? And then if we do move forward with a local in-person event, and now this would take into consideration the COVID restrictions, will your employer allow you to attend? Because we have been hearing some stories about employers saying, no, absolutely no travel, whereas others are, and when I say travel, I don't necessarily mean like across country, but just even attending local events. So we are interested in hearing from your companies or your employers, would they allow you to attend if we held something in person? And then, of course, we always want to know what topics of interest you want to hear about. And then if you have ideas for events for next year, such as, again, maybe assuming that there are no COVID restrictions, that we get together and have a social event, or maybe we have a lunchtime meeting in person, or a breakfast meeting, or other things. And I am going to try to bring up the survey right now. Maybe.
We just have a couple answers come through. They're still trickling in, Karen.
Okay. All right. Well, and so we'll give you a few minutes to answer these questions. The other thing I want to say is that there will be another survey post this webinar asking for your feedback about the webinar, and be gentle about the technical difficulties. We will try to figure that out next time better. And also asking if you're interested in participating, in, presenting, or providing, or volunteering in some capacity. And that will come out after the webinar. But while you are answering some of these questions, I do want to thank our presenters, Anandi and Brian, as well as, I am pulling up your name here. Oh, wait a minute. Our trivia winner, I'm looking for it. I know it's in here somewhere. And I apologize if I mispronounce this. Amritpal Agar, who is our trivia winner. You will all be receiving ICEA coins that look like this. These are from the Southern California chapter. We designed them ourselves. And you can see some of the images having to do with the Southern California industries here. And I guess I will, at this point, ask Chelsea, have you gotten enough responses in to be able to summarize any of them?
Yes, give me one moment. About 10 people answered.
Okay.
So let me. And you can look out for that other survey email in the GoToWebinar email that's going to be sent out after this webinar is done. Okay. Let's see. So for the question, do you prefer an in-person all-day workshop or a 90-minute virtual for the next event? 30% said in-person all-day workshop and 70% said a 90-minute virtual webinar. For the next question, it says, will your employer allow you to attend a local or in-person event? 30% said yes, 50% were not sure, and the 20% said other, so I'm not sure. And then, let's see. So some topics that are of interest, cost estimating, modeling, statistics, agile metric tracking, cost and schedule, optimistic basis, new iBots in controlling cost, MDAO trade studies with affordability criteria examples, machine learning, agile software estimating, natural language processing, data mining for cost estimating. And then for the final question, do you have any other events, ideas for events next year? Let's see. Networking events like a breakfast or a lunch, group dinner meeting, and that is all the results we have so far.
Okay. All right.
And I can send this to you, Karen, after the webinar is over as well.
Yeah, that would be good.
Yep.
And so again, if folks are interested in presenting anything, make sure you get in contact with someone, either the ICEA office or any of the board members. And here is all our contact information. And like I said, we will be trying to figure out the technical difficulties so that next time everybody who is scheduled to speak will actually be able to speak. We'll have to do some troubleshooting there. And again, we thank you for spending the last 90 minutes with us. Thank you again to our two speakers, to the board, and to Chelsea for handling all of the webinar activities. Okay, so I guess with that, I will wish everyone happy holidays and a happy new year, and we will be in touch again next year. All right, thanks
so much,
folks.
Karen. Thanks, everyone.